All right. So very quickly, in last class, in last two classes or last week, you guys had done this problem. Everybody have done this problem. Does it look familiar? Those are in the video lecture. Okay. By the way. All right. So I won't be obviously doing it here again. Let me see. We done this problem here in class, right? We didn't quite probably finish it, but in the video, the problem was again described, right? Right. So the solutions are here in the video is there in Brightspace. I have the solution and everything over there. So resources are there. Okay, for you to access, you just have to explore. What else? Let me see. Okay, so this problem, I did it in class. Remember? So the reason I'm showing it to you, you understand? These are for exam. The exam on Thursday. You know that, right? I didn't. That's exam number 3. So this problem is very important. I did show it to you. This is for exam. This is from chapter 6. Basically, again, the syllabus. Let me clarify the syllabus. Chapter 6 and 7. Now, depending on the book, which book you are exploring, right? If you're exploring Incropera, those are the 2 chapters, or Sangel. If you are exploring other books than Incropera and Sangel, you just have to know like Intro to Convection and External Flow. Those are the syllabus. Okay, everybody understand? External flow and intro to convection. Now, intro to convection and external flow, I did go through the equation manual here in class. Everybody remember that? Boundary layer thickness, thermal boundary layer thickness, hydrodynamic boundary layer thickness, the Nusselt number. Need you catch up with all the videos? It doesn't make sense. So, Nusselt number, Prandtl number, Reynolds number relationship, right? For different conditions, right? Like constant surface temperature, constant heat flux, in external flow, what is the critical Reynolds number, all sorts of things, like those are there. Okay, we did explain it here, all the equations. And the liquid metal, that's another important thing. Okay, liquid metal. Okay, so in liquid metal usually it's laminar flow, but they have their different equation. In the equation manual, I showed it here in class. Okay, so all you gotta do, that's the next thing I would like to show to you. You should be where's my equation manual? Content library. Yeah. So convection. So this is the equation manual. Everybody know like this is in Brightspace, right? Everybody know that, right? This equation manual. Therefore, this is in Brightspace. Okay. So I was talking about all those equation and the liquid metal. I wanted to talk about it a little bit. So that's why I'm here. You see what I'm doing review, and today's review is a little unique. Once I'll be done with everything, and then I'll be giving a practice exam. Okay, so you'll be trying to solve at least, or try to get the direction how you're going to solve it here. So this could be helpful in real exam here on Thursday. Make sense? And by the way, finally take home. Okay, we had 3 in class exam, 1 is take home. Make sense? All right, so finally take home. So after Thursday, I have only 2 class. That 2 class, I'm going to cover the internal flow. I'll start with internal flow a little bit at some point. Okay, just showing you the equation, not in math or anything. Okay, and a little bit of radiation. Okay, so next week would be a little bit extensive. Please don't miss the next week. Okay, because I'll try to give you a little bit with the radiation and a little bit of the convection internal flow, pipe flow. Okay, so very important class. Next 2 classes. All right, now come back here. What I was trying to say, liquid metal, right? So the liquid metal equations are here somewhere. Where are the liquid metal equation? Yeah, is it here? Full length paper, mixed boundary layer. Oh yeah, here. Everybody see that? So if you're gonna see a question on liquid metal, okay, in exam. So don't get scared. You gotta use this equation. You know where the equation manual is, right? If you want, you can print it. Okay. I obviously can print it, but we're restricted. Not restricted. We're told like if we can print, that is better. So I give you the access. You have everybody have some paper allocation. You can easily print it. Please print it. Okay. I think it's preprint, right, for all of you. So you guys have paper allocation, please print it. So equation manual, that's what you definitely like to print. Okay, in the equation manual, I'm just trying to give you even what you're gonna expect in the exam. You'll be expect a question from liquid metal, and you'd like to use this equation. Now there's 2 equations. Obviously, the first one for local, and the second one is for what? average national number. Okay, you guys remember what is local and average? What is the difference? Local means a pinpoint H value or Q value that we are interested. Q is the heat transfer rate, right? Or it is the convection coefficient. And average means if you are talking about the whole plane, that's the average. Average Q or average H, right? If you know the average H, then you know average Q. Does it make sense? Because Q equal to HA del T. Okay. And the average H has a bar on the top always. H has a bar on the top, right? So that's the equation. You see? So when you have a bar on the top on H, then you should have a bar on the top on Nusselt number as well. Always remember that, okay? So Nusselt average means bar on the top. Nusselt local means no bar on the top. Okay? Liquid metal, you understand? If you understand those two equations, any question with those two equations, you should be able to solve the exam question, the one liquid metal question that you'll be expecting easily. Okay, what are you going to do again? You should be looking for some parameters, or you should be looking for places to find those parameters to find the Reynolds number. Always remember that. That's the first thing you want to do. Once you find the Reynolds number, you remember Reynolds number, everybody? Reynolds. I don't know if I'm pronouncing correctly. Reynolds. Okay, Reynolds number. Once you find the Reynolds number, the L I'm not pronouncing. The Reynolds number, then you're going to compare whether it's laminar or turbulent. Now, in liquid metal, are you expecting it's turbulent? No. Usually liquid metal, it doesn't move that fast, right? So usually it is the laminar flow. But you really don't have to, when you're dealing with the liquid metal, you really don't have to find the Reynolds number for transition value. Rather, whatever Reynolds number you found, turbulent or laminar, doesn't matter. You just simply put it here. You see Reynolds number on the right side? And the Prandtl number you're seeing as well. Where are you going to find the Prandtl number? Say if you're dealing with steel, right? Table, appendix. Where do you find the appendix? Uploaded in Brightspace, right? If you have a book, bring it. Okay? Or electronic source, electronic book, bring it, bring the laptop, whatever. Log in here, get the appendix, okay, whatever necessary. I don't mind. Just get the value from the appendix, okay? If the Prandtl number value you need to find, it's not given in the question, okay? Most likely it won't. Most likely you have to find. That's another task, right? That you know how to find the Prandtl number. I did show it to you in class though, right? It's in the table. Any question? Everyone understand? So liquid metal will be one question, okay? And remember the other question I was showing it to you, H bar integration, we did it in class. That would be another question in exam. I'm just giving you what will be in exam, okay? So you know what to prepare. So you should be doing what? If I've been in a position, I should be practicing that problem that we did in class, like the integration H and H bar. I should be doing it at home right before Thursday. I should be doing one liquid metal problem from book or from the video lecture that I uploaded. I believe I had a liquid metal problem over there. Or the homework, right? The homework has one liquid metal problem as well. So I should be doing that, reviewing that, right? And if you just flip any book, like in Propedon or the subject, you should be seeing a liquid metal problem over there. Solve. Okay? Take a look on that, do it one time. So you definitely want to do at least 4 problems before coming to the exam, because in exam you'll be expecting those questions, okay? So that liquid metal question, that average integration question, right? Then you'll be expecting a question, the thing that you're doing in a homework, in external flow, what you do, like you find the critical Reynolds number, you compare, use the table, like whether the laminar flow or turbulent flow, use the condition like whether constant surface temperature or constant heat flux, right? We did it in class. If you watch the video lecture, you know what I'm saying, right? I had those problems solved over there, right, Steve? Okay, so that is another problem that you'll be expecting. And the final problem that you'll be expecting, let me give you an example. So that is the equation. I'm going to just point it out here. That is called flow, and in homework you did it. Okay, in video I did solve that problem, something similar. So that problem is like something like flow around the object. What does it mean? Flow around the object means it's external flow. It's not happening inside the conduit, right? It's happening outside the object. Okay, but if the object shape is like cylinders or square or different shape, what kind of equation that you're going to use? So that's another problem that you can expect. Okay, and there are equations. Let me show you the equations first. Okay, so the equations are. So this is the equation. What does it say? flow around a cylinder, right? Flow across the cylinder. So does this equation looks very scary? It does, right? But take a look here. It's just as algebra. It's complex algebra, but it's algebra. Why I'm saying that? It's on the left side, as usual, we have the Nusselt number. In the right side, we have bunch of complex thing, but it's a mixture of what? Nusselt number and Reynolds number. So if you can find Reynolds number and Prandtl number. So if you can find the value of the Reynolds number, do you know how to find the Reynolds number value, everybody? What to find the Reynolds number value from the table? You gotta find the row. What else? You gotta find the viscosity. Now it could be the kinematic viscosity or it could be the dynamic viscosity, right? If it's kinematic viscosity, in some books, the reason I'm saying that, if you're exploring the Hydrophyta, they have the kinematic viscosity, which is mu over rho. That means you don't have to find the rho or mu separately. Mu covers everything. And if it's like dynamic viscosity, which is in Sanjel, they have the mu and rho separately. Okay, so that you have to find both of them and find the Reynolds number. Bottom line, you have to find the Reynolds number. Okay, somehow. Now, in external flow, still you remember we had the length of the plate, right? That's the external flow thing, right? For the cylinder, flow around the cylinder, you see, it's not important how long is the cylinder, because the flow is coming across the cylinder, right? So what it could be the important? The diameter of the cylinder. I'm assuming that my hand is a cylinder. Does it make sense? So the diameter of my hand. Okay. So when you're gonna find the Reynolds number, you're gonna use the length of my hand or the diameter of the hand. The diameter. Everybody understand this? Okay, that's flow around the cylinder. Now, other than that, everything is pretty much straightforward. Why I'm saying that? You're gonna find the Nusselt number. You know what is Nusselt number? It is H D over K, in this case, D. In external flow, we have H L over K, right? Here is D, right? So the diameter is known for my hand, assuming there's a cylinder. The K is known. The K would be for my hand K or the air that is flowing there. The air, remember that. And the Nusselt number, the K or conductivity, is not for my hand, it's for the air. Okay? So you can find the air K from the appendix. You know the diameter of my hand or cylinder, whatever it is flowing, and then find the value of the H. And again, that is when you already have the value of the Nusselt number. Okay? If you have a value of the Nusselt number, you know the relationship of the Nusselt number, which is H D over K. D and K is known, H can be found. What are we going to do with the H? To find the value of the Q. Always remember, that should be in your back of your head. Always remember what you're doing in the heat transfer class. You're trying to find the heat transfer rate or Q. Okay? That H is going to give you the value of the Q, right? Definitely remember the Q equation, which is HA delta T, right? Difference. In this case, what is the delta T? The temperature of my hand or cylinder and the temperature of the air. What is the A? The A, now you need the hand length. The whole surface area. Chelsea, you understand? That's your A, right? You know the cylinder surface area? What is the equation for that? 2 pi r, the circumference multiplied the H, right? H is the length, right? Think this way, this is the cylinder. 2 pi r H, right? So these are the things kind of not covered in class, directly assumed, implied. You learned it in high school or someplace, or you are smart enough to figure it out, right? Somewhere. Everybody got it? If you got it? Any question? Perfect. All right. Actually, now we are 100% ready for the exam. If I could have given you the exam, you should have done it well. Okay, these are the things you'll be expecting in the exam.
You probably already said this. I had stuff, so I can't remember. When is the exam?
The exam is on Thursday.
Okay.
Yes, and it will be in class exam. The final will be take home. That means I have after Thursday just 2 classes left. Those 2 classes are so important. If you are into heat transfer, so important because I'm gonna cover 2 things on these 2 classes: internal flow and a little bit of radiation. I told you at the very beginning, we never had in time. When I was undergrad, we had like 3 credit hours courses for heat transfer, right? That is the only way to deal with that. Other than that, I mean, I can jump all around here and there and try to finish everything. At the end, possibly you don't get that much out of it, okay? So I really don't want to go on that route. Yes.
When's the final project due, did you say?
The final project you can submit it end of week 14. It's fine. Yeah, end of week 14. Don't go end of week 15. then I don't have time to grade.
Do you want everyone, or do you want
Everyone. That data taking should be one per group. But analysis, everyone. Okay? Once the data taking is done for group, just get the data. You can possibly use the same figure, everyone, but I would suggest, that's my recommendation, to draw the figure by yourself. Okay? That is good. Okay? If you're getting the figure from your group, you possibly don't know exactly what is going on inside. Okay? Means like the slope, how to find the slope and everything. Okay? How to draw the plot. So those sort of things. I know you guys are smart enough to deal with that now. So, but still, that's my suggestion. But I want individual report. Okay? You see the Dropbox is already there. You're gonna submit your data taking as a group. Okay? Maybe the plot is as a group as well. But other than that, the analysis is your thing. Okay? If you just participate on the data taking and just plot it, you'll be getting 60% out of it. I'd be happy. You know what I'm saying? You'll get the passing grade already on the project, just to encourage you something. If you did the lab, means take the data and plot it and get the slope, immediately you'll get 60% or more. Okay? And other points like the analysis, we're gonna give you the more and more points. Usually everybody got full points on the project. Yes.
Are there going to be 2 questions in class next exam, and then?
For exam, yeah, most likely because there is never enough time. Okay. Yeah.
And so, are we gonna have a take-home part next exam too?
Yeah, most likely because there is not enough time. Okay. I want my students to be relaxed in the exam time. Okay. So they can reflect exactly the way they learn it here. The way I'm teaching also kind of relaxed approach. Okay. So I'd like them to be relaxed in the exam as well. But at the same time, they should learn or know what is happening. Okay, that is the goal always. Anyway, moving on. Oh, what is happening here? Moving on to one of the main agenda for today's class, right? So which is I do have a practice exam. I'd like to show to you here. Okay, so here it is. I do have a, by the way, so don't get worried. I do have a practice exam solution manual as well. So this question that you are seeing here, I do have the solution for all of them. Okay, so now I'm gonna give you the practice exam solution manual. Means I'm gonna upload it in Brightspace after this class. Okay, don't worry. So there are like 4 questions, right? Something very similar that you'll be expecting in exam. Okay. So if I'm in your position again, I'll be solving all those problems before coming to the exam. Okay. I'll make sure. So yeah, this is what you're gonna do. I think I give you enough, right? For the review kind of thing. So instead of doing some new problem, jumping all around here, I do have a very formal approach, like formal questions here and the solution manual for these questions. I'm gonna upload both of them in Brightspace. Now it's your responsibility or job to do as much as you can. Now obviously 4 questions you can do it in 1 hour. Okay. So what I'll be doing if you're in a position, I'll be expecting you at least start to write not the events find out thing, the main equations. Okay. Try to write the main equation, how I'm gonna solve it, and try to touch all 4 of them. Okay. And while you are doing it, obviously you'll be exploring what the solution, equation manual, all the things that you took in class note, right, from past lectures. So you should be reviewing them. If you have a book, open that up. Okay. Start. Your goal should be within 1 hour, every 15 minutes. You should be able to solve at least one of them. I'll be walking around. This is very important. So you want to talk with me, okay? You want to talk with me regarding anything and everything that come up in your mind with any of the questions that you're seeing it over there. Yes. Yes, definitely. Go down and get a big look. Not in Brightspace yet, but I'm gonna. Can you not see it clearly? I can upload it in Brightspace. Yeah, definitely. I can do it. Let me upload it in Brightspace. Yeah, no problem at all. So
I'm already logged in with Brent and all that. If anyone wants to copy it.
okay. I don't know, it's taking a little time. So exam, under this exam, let me create a folder called exam 3. Okay. Under this, let me create another folder actually. Okay. Let me create exam 3 practice questions. Okay, so there won't be any confusion because I'm gonna upload the exam 3 already, exam 3 on Thursday. So on that day, a student may get confused if I gonna have it under that. So practice exam 3. All right. So everybody, you see where it's located? So there is a folder under this exam that called exam 3 practice questions, and on that folder there is this practice exam 3. Okay, and then I'll be opening it up. Okay, so I'll be make it bigger, and as I said, you should be asking me question, anything and everything that you have regarding this. There is, by the way, one last homework for internal as well. Okay. On that homework, I just have 2 questions.
It's not currently uploaded. When will you upload that? Or upload that?
I can upload it right away, but internal I haven't started it yet. On week 14, I'm gonna start. So that will be due on week 15 during the exam, final exam due date. Okay. So you'll have some time on that. You see, the second problem is liquid metal problem. Marker is liquid metal. Okay. The last one is the flow across the cylinder. We covered very specific material, and all of them will be solved in class and in homework. I'll upload all the solution manual as well, okay, before Thursday. So, but today I'm gonna upload all the solution manual related with this exam. Anyone needs a helpful? You need some copy of the exam? Thank you, Chelsea.
Thank you.
One other extra.
And you know, if you had any past submissions, submit it. Um, submit it so you have some decent grade, right? But the thing is, like, if you're submitting something very old, you'll be getting maximum 5 out of 10. But at least you have some points out of it, okay?
Have you graded everything up till now?
I don't know. Last week, before I left, I think everything was up to date. Now I gotta check. This week I haven't touched it yet.
I don't agree.
7 was not graded yet.
Not yet.
Okay, all right. Does the 8 is uploaded already?
It wasn't as of earlier today.
No, it's not.
Okay, so 7 is what? 7 is like the external flow, right?
Yeah.
You can just give us all A's. It's okay.
No, it's all right. Today, so this is my homework as like your homework. So finish the homework 7 grading, homework 8 I'm gonna upload, okay, and I'll upload all the solution manual as well, okay. So you have every resource for the exam.
Homework 7 was Introduction to Convection.
Intro to convection.
Yeah.
Did I upload homework 8 also?
No.
There's no homework 8?
No.
Interesting. Supposed to upload the homework 8. So everybody have the question, right? I can do other things?
Yeah.
Okay, perfect. Oh, no, that's the reason. I did upload the homework 8. The problem is, you say, that's not
We can't
visible
see
to
it.
you, invisible. I'm sorry. I said, "Okay, that's why you're probably not. Oh, I'm sorry. So here's the thing homework 8, and there is one more homework 9. Okay. So this homework 8, now that just now you see it, my suggestion would be do it as well because that's related with exam. Okay. And I'm gonna upload that solution manual anyway with this homework. Don't look into, I mean, I don't know what to say, but look into the solution manual because you will need it for exam, okay? So homework 8, but submit it at the same time, okay? Submit homework 8, the solution manual, homework 6, 7, and 8. I'm gonna upload it, okay? In Brightspace. Alright, so you said Mitch, homework 7 was not graded, right?
Yeah.
So homework 8, please submit it by next week, Tuesday. Even though the deadline says April 16, as you can see, well past, right? I was make it available to you long ago, but it was invisible all the time to you guys. Okay, so hopefully you are not too much overburdened. Seems like at this point, since homework. So you see what I'm not gonna upload any more homework, like okay, because homework 9, I'll upload it. I'll upload the solution manual as well for your reference only, okay? Because you guys have to deal with this homework, exam 3, exam 4, project, and homework. It would be too much, okay? So I don't want you to deal with 2 homeworks. So this is the last homework 8 that you gotta submit. At the same time, I'm gonna upload the solution manual also.
Are you gonna upload a solution manual for this practice?
Yes. I have the practice solution manual as well. After this class, I'm gonna upload it. Okay. You want me to upload it now?
You don't have to upload it.
So if I can upload it now, you see what will happen if you're gonna look into the solution manual, you're gonna resist yourself to thinking like how to solve it. So you gotta first try to think how to solve it. Okay. If you see the solution manual, never you're gonna find it. Okay. So in this class time, I mean whatever time left now, 50 minutes or whatever. So you should be thinking how to solve. At the very end of the class, I'm gonna upload the solution manual. Okay. I'll talk a little bit of the solution manual as well. So before that, just try to think how to solve by yourself. Some graded exam. For example, some of you are missing. Let me bring it. See. All right, Jesse, Mitch, and Harley. This is what you guys need. Take your data.
Okay.
Before the problem is the class.
And it's always like that, like, it's just, you have one. I don't think this is. No, you add one to the top. Yeah. And then you divide it by that same. Yeah. Yeah. So, and then you just plug in your first one to that, and then subtract the five, plug in the second. Yeah. How did you decide on that? Oh, is that the power pack? So it's here and next. So it's here. It's not.
Yes. What's up, Diego?
So C run is just a constant. So you're just doing that.
Hmm? And then what do you see? You got to find the value of the equivalence number. No, the value of x equal to equivalence number. See, if this is the whole rate, right? At some point, the some points there as well. And so you got to use what you have there are some others you have it in your life. So you got to use that value and you have XC for that relation. So then you go to the relation with XC and XC to L. So that XC you will find it. So we have the class lecture from class. So we did solve it in class. Do you have the class lecture? Yes, class. Okay, do you have it? So we did solve the same problem, very same number. Okay. So other than that, it's really difficult. So you know what? You log into this computer. All the video lectures are in Express. I'm going to show it to you. Because other than that, it's difficult for you to now. You want to log into here?
So like here, so
Log into this computer. I'm going to show you.
you can go out here, so if you want to grab something, right?
Yeah, log into this computer. So open the video lecture in this class, and then I'm going to show you. This is local, yes. But you got to do integration for the local and the target. Yes. But you need to find the value of the XC. That's what I'm saying. Like, open the video lecture. I'm going to show it to you. Otherwise, if you could have like the class lecture, I could have showed to you from there. Yeah, open the video lecture corresponding to this class. You don't have to put the sound on. The sound is not necessary. I could have shown I could have shown here, but the problem is I got to put all the portions here. So, is it coming? We'll have the video lectures for all the classes. Or if you submit the homework, did you submit the homework? So you see, the homework, we have a similar problem. Homework 7. Homework 7, we have the same problem. If you could have submit the homework, then you could have known. And in Brighty Space, I have these solved problems also, okay? Therefore, come here, this computer, log into this computer. If you could have done the homework, then you could have known what to do. Come here. Log into this computer. I'm going to show you Brighty Space. Log into Brighty Space. I'm going to show you what to do. I do have the solve problem as well in Brightspace. Yes, you done? Any question? No, Zeus XC and XC for the tablet, yeah. For the tablet, yes, it's a little confusing, right? It says like tablet right? Find that, right? But when it comes to that tablet, you actually should include both of them. There's a mix there. So don't be confused with the H tablet. So you gotta find both H laminate and H tablet. And then H tablet, right? So you gotta remember stopping the solution and then after a bit. No, not me. Yeah, we must have a solution. I do. It was probably homework set. Oh, this is homework set. So no, go to homework 6. Okay, so go to the model. Model 6. Yeah. Now you already. Yeah, that. Yeah, so that's the average. That's that. So you have these two parts you will together. Even though it's a tablet and if you get increasing, just forget about the tablet term. So you basically have to find the lemma and tablet both. And then do this. For anytime it says interpolate, you gotta do this. Both. Okay. You open the Brightspace? Then go to module 6. Go down. Did you read any of these things? You got to read a lot of materials afterwards, so yeah. Open this. It's not. It's for your own sake.
Sorry,
Go down.
what meters right
So
now?
this is the see, you have this
I
XC in
mean,
This is how you
I don't know. It's got 160, but
understand? What's that XC? This is exactly what
solve
I'm
it
doing.
here, and then maybe solving this, I don't know.
With the limits
I
of
don't know
XC, XC.
how solving this from this X and 2X.
Okay. That's right. You see how much things here? If I could have started to explain, you would never understand it. We spend like one class on this problem. Okay, more than 1 hour is spent on this problem.
X would be 0.5.
Which on Brightspace page, pretty much everything is there. Go to Brightspace, go to module 6, you will see there are these problems solved over there. Yeah. Go to this class. Go to module 6. Okay.
Right.
So
How would you solve for
So you have to solve for
go down. See practice problem 1 and 2. Practice problem 1. Open both of them.
you
You
assume
guys have this.
the Reynolds number is 5 times 10 to the fifth. Then you use that to solve for the XC problem. You just flip like
Go down.
But
This is the similar problem.
or do they use?
You have to do integration. We did it in class as well.
This
This one is
so you would just solve from
I saw Chelsea, you already saw what we said, right?
You use the
All the
Reynolds
modules are in
number,
Brightspace and everything.
what you
Where you know everything is in the right place, right? All the modules, all the questions, this practice problem, everything is out there as well.
Then you use the equation like the Reynolds number, and this is the length, like where the transition is, so the angle lengthener. Actually,
And as I said, at the end of this class, like after 20 minutes, I'm gonna upload the solution manual for you for this practice exam.
and that gives you actually.
I need to do.
Is the solution manual gonna still be up when we're taking the classes?
So basically,
Will we have the solution manual up?
you know this,
Even
this
when
is
we
the
take
equation
the.
to get that.
Oh, you got it.
This whole thing.
Yeah.
Yeah, that's it.
By, yeah, this is the.
Yeah, that's part of the note.
So every.
All the homework solutions, all the things that are uploaded, yeah, that's part of the class. Okay? You can use it during the exam.
I need to see. I didn't do it.
Everything electronically you are seeing it.
I didn't do that stuff, but I've never used that.
It's like similar to when.
Okay. Oh, it's like doing everything again, yeah.
Homework 7.
Done?
Yeah.
I mistakenly uploaded the homework 7 solution is actually the homework 8 solution.
Okay.
So, to give you an idea. So homework 7 solution I'm gonna upload and I'm gonna change the link.
Is the homework 7, is it the solution to homework 8? Is that still up? Thank you.
I gotta upload it anyway because I didn't make it together. This is my fault, right? So now that the exam is on Thursday, I can't hold it on my side. I gotta show you what's the solution for that one.
You still want us to turn it on?
Yeah, definitely. You still need to turn it in because you need to solve it. Once you solve it, once you're gonna do it, you'll understand it. Okay. Remember it.
So this is the solution manual for homework 8?
Yeah, that's what I'm saying. Yeah.
I'm trying to remember for AC. I think that'll help.
He didn't say.
It's not your fault.
He
He
said,
says
oh, no,
my
no,
fault. That's what I said.
I was trying to screw this.
So I put it like 2 weeks ago. I forgot to make it available to you guys. Okay, that's the reason. You understand it.
It is too big for it. He didn't seem too concerned about.
I can't remember. I don't usually.
You're not doing it, Mitch. Where are you going?
Well, I got like one of the minutes. I already did I did the first one. I did
See, like,
the I got the second and the third one set up.
Okay.
So I'll be working on that later today.
You know what is this?
Yeah, an iron gun.
Iron gun. You're gonna get the temperature. See Chelsea and Harley. You guys two of you work together, okay?
Yep.
So talk with Chelsea. Chelsea, you're okay with this group?
Yep.
So let's talk with them. You would like to take the data. Harley knows what to do, but you want me to show one more? What? Chelsea, you want me to show one more time? Yeah, the
I
last
can-
time
I
haven't
can do
finished
that.
yet.
select an air
It's
speed
12.
for your-
Oh.
Yeah, I gotta be here for other students, okay? For
No,
15 minutes.
I didn't realize the time it wasn't a lot.
Do like.
Alright, so I mean,
when
what
it
you
first-
can
you'll hear
do,
it when it first starts,
you know-
like, ramping up.
Yeah,
so
no,
start there,
going
and
anywhere
then
yet.
pretty even
Okay.
further.
Okay.
And we'll do that for your second speed. Otherwise, we'll be there for an hour.
Mitch, I have the class haven't finished yet. I can show it to you now. I will wait 15 minutes. Now, one thing you can do is you have to go, must have to go, reading that block. You see aluminum block over there?
Yep.
Let me go grab it and say, I need to explain it and process it here. You feel like you good? I'm coming back, just 1 minute.
Hey Logan, what's up? When it says, determine the local convective heat transfer coefficient of the trailing edge, is that just means so so just we set it equal to the outside. Okay, because I was trying to think of what kind of, okay, because I think we've had a problem like that. We actually use certain sources. Okay. That's one of my lines right there.
So we'll have a different value here. Don't worry. Yeah, it was. What again? I had 80 and all right, so Chesney and me. Let me take some times here. For both of you. Harlan will come tomorrow, as we were saying, in travel. He's in travel. Okay. So this is the plot that he will be using, and this is the meter that it is in financial application. Now there are like 5 parts of this experiment. The first one is called natural convection. What it means that you have the heat gun, right? You're going to use it to raise the temperature to 60 degrees Celsius. Okay. And once the temperature gets raised to 60 degrees, you are going to wait till the temperature drop to 30 degrees Celsius. Okay. So 60 to 30. You don't want to wait till this thing comes to room temperature because in natural convection it will take forever. Okay. Makes sense? So still it might take 45 minutes. Let me ask them. Logan, how long it takes for natural convection to come into 30 from 16?
From 60, like an hour and a half, maybe.
Huh?
Or more. Like an hour and a half or more.
Hour and a half? Yeah. So that takes way too long. Okay, that's probably the longest one, right? The others, how
Others are about like max 30 minutes each.
30 minutes each max. Okay.
Depends on the speed.
All right. So if you guys are too much in hurry, I don't mind if you're gonna get the temperature reading from 65 to 35. Okay, that way it will be much faster. Okay, but you at least have to have a gap for like 30 degrees Celsius. Okay. All right. So still wait. Wait for expecting hour we're gonna take and expecting you're gonna take the reading of the temperature every minute. Okay, along the way. So every hour. So if it's hour and 30 minutes, like 90 readings. If it's hour, then 60 readings, right? So that's the natural convection. Any question? Nope. So once you have the natural convection, what you need to do is that you have it printed here. You see, this is called natural convection here. So you're gonna log the time and temperature here, right? And these two are enough to get what? A plot like this, right? Okay, it's a little tricky. How you gonna get the plot like this? You have the time. You don't have the temperatures directly like that, right? So what are the temperatures that you're seeing here? You're seeing the temperature of the ambient. Do you expect it to change? No. You are seeing the temperature of this block. Do you expect it to change? Yes, definitely it's going to change, right? And that's the temperature of T here, right? And it just says which is what. Okay? And in the nomenclature. And then you are seeing the Ti initial temperature. Do you know the initial temperature?
Yeah.
Yeah, so you do have that value as well. So once you have all those values, you should be able to find this ln of this ratio. And in the table here, you don't have a space for that, which is perfectly fine because you gotta do what? draw. You gotta create an Excel file. Over there, you literally take these readings from here to the Excel files, right? And you gotta create another column, which should be for what? For this thing. In Excel, you know how to do the math, right? You have to do this math to find the new column values, right? So now you have the time value and these values, like log and dimension value. And then from these, you're gonna able to draw these, right? Like this plot, obviously. And now, when I'm saying draw this plot, you're obviously not drawing a straight line because these are experimental data. You'd be getting like the bubble points or some kind of marker, right? I don't know, triangle, whatever you prefer. But those drawing points, right? Once you have those, you need to get a best fit curve. You know in Excel how to do best fit curve? And you right click on this data, so that best fit curve is there. Once you have the best fit curve, can you get the equation for the best fit curve? Remember? So from the equation, can you get the slope? That's the slope we need. Okay. So from that slope, you should be able to find the value of the h. Make sense? You see, so these two ratios are the slope, right? So you're going to find the value of the h, like this, and the t will going to go down, right? This is the equation. And from there, you have the as and c. M is the mass. You can find the mass of this block, right? You can find the c value for this block from the table, right? And you can find the value of the surface area. Can you do that? The surface area of the block is calculated easy. So can you find the value of the h? So again, this divided by this is the ratio. So this is not given. This is intentionally not given. It's hinted. So you kind of can figure it out by yourself. But I'm kind of giving the solutions anyway.
Do we know what type of balloon it is? Like what grade it is?
No,
So just
I
basic
this
balloon.
students made it. Just use the can I use it?
Yeah, go for it.
Awesome. So you see the slope that I was talking. What is the slope? This is del y. This is del x. Del y. This del x is del t and this del x is del of
Oh, the
log.
slope is defined.
Yeah, so t minus tk. Okay, ti minus tk. You understand? So this slope, the equation y equal to mx plus c. The equation is going to give you the slope. This is your m. You understand? So this ratio is this ratio. If you're going to move this t here down, this is the same ratio. And on the right side, you have this HA and MC. You can find the value of H. Does it make sense? Little bit thing I lied. I didn't quite give it directly. So then it would be not a college, it would be high school. Right? This is college, you can figure it out. Does it make sense? But even though I will kind of give you the solution anyway, I make it high school now. So you have this first experiment, you understand? So there's the natural convection. What is the other four experiments that you have actually? So one of them is like, I don't mind if you're gonna work together, do the calculations together, like as a group. It's for everyone. I don't mind if you work together, do the calculation as a group, but I do mind if you just copy other words, means like you printed other words and submit the other words to me. When you work together, you are discussing, you are understanding, you are solving it, right? But when you're submitting, you are writing it. You are doing the Excel. You are doing it by yourself, right? But everybody together, maybe. But you're doing your part, okay? And submit. So that way, you're gonna learn. Otherwise, you won't be. You are just simply probably copying other words and submit it. And end of the semester or later in future, I don't like it. I don't learn anything from your transfer. You'll feel like that way, okay? At some point in your life, right? Anyway, we do still do that, right? 25 years ago when I did undergrad, I still remember which class I learned, which class I didn't learn, right? So it happened. Anyway, you understand the first experiment. The second experiment is very straightforward. So you're going to raise the temperature again to 60. You took this time, don't go to 60, right? Go raise it to 60, right? And now you put it inside that where you bring it on, right? Inside that wind tunnel. Okay. So once you put it inside the wind tunnel, and there's two different ways you're gonna do. Say like airflow coming this way, this is the 90-degree angle. This is the way you're gonna put, right? The other one would be you're gonna put it at 45-degree angle. Here it's coming this way. And other things are pretty much the same. It means like recording the temperature until it comes down to 30 degrees Celsius or something like that. You understand?
So we should be probably measuring off the same spot every time, right?
Yeah. It doesn't matter. This is very highly
And it's
conductive.
gonna be the same temperature surrounding for the
Surround.
most part, because it's the same material.
It's same material. Now, not only that, but it is highly conductive.
Yeah.
As if like, in chapter 5, we assume this is like a single dot, right? This is so conductive. It's every point, the temperature is not changing at all.
Yeah, but the wind is going to be pulling more heat and energy out of the.
Oh yeah, that is a good observation. Heat and energy could be dissipated
this
more
side
here.
will get
Yeah.
the heat
Yeah.
transferred out a lot faster than back here.
Back here, yeah.
So if we measure up here and then we measure
Up
back
here,
here,
on
The
the
chances are we are going to
Drop.
be measuring from back here, given that the
Yeah.
wind tunnel's kind of.
So those details, I'm leaving it to you. You guys can decide whatever you wanna do. I don't mind. But yeah, I agree with each point. Try to get it at one single point, wherever you're measuring. Front, back, side, left, up, north, bottom, doesn't matter. A single point, okay, every time. And usually the way this experiment is done, the reason I'm kind of emphasizing on this point, you see this thermocouple bit here. So when this thing come here, resting on the top, it is in contact with this thing, right? And if you have a thermocouple meter, you can literally connect it with the thermocouple meter and get the same reading. If you have a Raspberry Pi or other things, you can get it like, and then digitally in the computer as well. Or whatever. This is one way, the same thing. And the reason I'm saying that, you would be getting the temperature at some point, like a single point inside somewhere, right? So anyway, there is little chance you're gonna get a little bit of error by using this ion gun though, right? And then does it just have own error? You know why? Because you gotta actually put the emissivity on this. Okay? If you don't put the proper emissivity of this material, when you're measuring the temperature of this material, you would be not getting the 100% temperature. Okay? If you're getting somewhat close, they're not 100%.
Yeah.
Okay. So that's one thing. Okay, come back to the experiment. You see, there are like, there are 3 modes. 1, 2, 3, 4, so 4 modes, right? So these two angles, you understand, 90-degree angle, here is coming this way, 45-degree angle, here is coming this way. So these two are from that, right? Every time you go to raise the temperature to 60 and then come back to 10. Now, when you're measuring those two, you gotta understand it needs to be at certain speed. The speed of the fan that is connected in the wind tunnel. You remember you had a control over there. There's a knob. Do you know where is the knob? Able to find easily.
Yeah.
It's just top of that somewhere.
Yeah.
Okay. So the knob needs to be in certain position. Whatever that position is, you don't need to use the period to find the velocity. But whatever the velocity, that is the one velocity you'll be using to fill out this two table.
Okay.
Two sets of columns. Okay. All right, for these two different 45 and 90. And now you gotta do the same here again for a different speed. Understand? Why you're doing all of this thing? Does it really have any effect on H value on these two different speeds? Yes, it does. More the heat, more the airflow, more the H. You know that. And when you be doing the experiment, getting all the data, find the H value by using this slope and everything that I was saying, you should be seeing the values different for H for all 5 of cases. Right? When you're doing natural convection, the H value should be very low. When you're dealing with very high speed of the air, you should be expecting H value should be very high. So if you're seeing those trend, okay, you should know like you're doing the right thing. Now here's another thing: the values of this H. If you find, so you see the sense, no sense, nonsense values, right? You remember that. So if you're seeing the values of the H is like way too high, that you know it's a nonsense value. If it's like 0.00 something, it's a nonsense value. Usually the convection value for natural convection, and then if you find the nonsense value, that means most likely you are doing some error or doing any calculations here. Okay, you understand, with the units or something. Okay. Now what I'm saying, like Logan, you done? Any questions? Huh?
So I did the first two.
That's true. You have any questions and anything? You know how to deal with the other 2 questions? Okay. I'll upload the solution now just after finishing up the time. Okay. All right. So now.
Back in the lab later.
Huh?
Oh my God. Holy.
I'm sorry.
I
The block?
was like, I
You need the block?
recognize that dot.
Later on, I come back to very fast.
You can take the block now. I'll just bring it here for explanation. Okay? Guys, this block will be over there, okay? Logan is going to take it now. You understand everything now?
Yes.
Oh, yeah.
Okay, 3 of you are going to do the project.
When would you like to meet up to coordinate?
One of you 3.
I have a
Three,
decent
four.
chunk of time tomorrow.
What time tomorrow?
Because I only have like that.
Make sure Harley is with you guys, okay? I want everybody to.
I'm free after like 11:30.
After 11:30.
That works.
3 works.
And I could always.
Want to do
we always,
11:30 noon? 59.
Yeah. And we could always also split up the